I just want to explain jitter matters. So why is jitter so important? This used to be a term that was always mentioned in the industry. Lately, people have forgotten about it. But if you think about it, if you combine high throughput, multi-channel signaling, as well as low latency interfaces, jitter is really going to mess up your signal quality. So you need to have test equipment that has really low jitter performance so that you can really characterize the high-speed interface that you want to qualify. So we are introducing the QCA, our high-speed communication analyzer, to be able to characterize high-speed interfaces and really understand what is the signal quality of your interconnect. So this is a big pain point in the industry because in R&D, it really doesn't matter how much money you spend on the equipment, but if you start scaling your technology, so you go to high volume testing or high volume manufacturing, whether it's for electrical ICs or photonic ICs, you really need to look at your overall cost of test. And this is where we are going to play a critical role. This is a scalable technology. You can put a lot of channels in a small real estate, and as a result, you can really reduce your overall cost of test. And quality of the test equipment is really critical. So we have to have an extremely low jitter noise floor to be able to characterize the high-speed interface. So that's why jitter matters. It still does. And this is our logo for the new product. So for people who are not really familiar with Quantifi Photonics, so our company focuses on test and measurement solutions for integrated photonics, silicon photonics, and high-speed interfaces. So of course everybody's talking about 200G, but it's still a couple of years away. The most of the interfaces that are going to be installed today are going to be 100G. So if you need to have a test solution for the characterization and validation of those interfaces, you need to have a solution like this. Quantifi Photonics also has photonics test solutions, so laser sources, polarization controllers, like tunable lasers, optical arrays of optical power detectors, as well as optical spectrum analyzers. So really to be able to characterize the photonics link. This year or next year is going to be an inflection point for silicon photonics. We're working with all the key customers to make sure that they're ready to produce silicon photonics in high volumes.